So this was a weekly pop quiz 2, which was related to the structure questions. Question 1A, any doubt? The difference between a scalar and a vector quantity. Question 1B, any doubt? On a figure, draw a vector diagram. We have the two forces are given, 6 Newton and 8 Newton, which are acting at a point. Both forces act away from point P, and the angle between them is 40 degrees. Figure 1.1 shows the two lines at an angle of 40 to another. On a figure 1.1, draw a vector diagram to determine the magnitude. So how it can be done? You can use a parallelogram method here. As you have the two vectors, but you have to select a scale. Like example, if I select 1 Newton is equals to 1 centimeter. So if I have a force of 6 Newton, I will draw 6 centimeter. And if I have force of 8 Newton, I will draw 8 centimeter. So using a ruler scale, you will draw a line of 8 centimeter. You can do a triangle method as well, but because the diagram is given according to the parallelogram, that's why it is much more easy to just draw the parallelogram. As I don't have to use a protector here. But if you do a triangle method, that's fine, but it will easily work with the parallelogram method. As the angles, we don't have to measure. So 6 centimeter and 8 centimeter. I will open the compass 8 centimeter, draw an arc, like open a compass 6 centimeter, place it here and draw an arc. Open the compass 8 centimeter, place it on other side and draw an arc. When I join this intersection of these, like the position of the arc and intersection of the line, it will be a resultant. So we'll measure the length of this resultant by using a scale or a ruler, and we'll find the value for this resultant. That's the parallelogram method. If you want to do the same question by a triangle method, so you draw one of the vector. Example, I drew 8 first. Then at an angle of 40, because the 40 is with the horizontal axis, so I will draw the second vector, which is 6 centimeter. So draw the second vector, which is 6 centimeter. The Pythagoras theorem is not possible here. It's only applicable when the vectors are perpendicular to each other. From tail of the first to the head of the last, that will be my resultant. And I'll measure the length of the resultant, and that will be the magnitude of the resultant. So either a triangle or a parallelogram method will work here. Yeah, this angle has to be 40. Like this angle was given 40 between the two vectors. So this angle will be 40 degrees. The best way, whenever two vectors are starting from the same point, use a parallelogram method rather than a triangle method, because you already have the angle. So you don't have to draw anything. Just complete a parallelogram, draw an arc, complete a parallelogram, and draw the diagonal from tail of the first to the head of last. No, the resultant is not exactly halfway. That is not the right concept. The resultant is not exact. If the two vectors are having a same magnitude, like example, if this was 8 Newton, this is also 8 Newton. In that case, the resultant will be exactly halfway. In that case only. But if one of the vector is having a greater magnitude than the other, like one is 8 Newton, another one is 6 Newtons. So the resultant is more towards the 8 Newton. So it means this angle of the resultant will not be half, it will be more towards the higher value. Question 2, any doubt? Question 2, part A, B. Any doubt? Part A. The theory suggests that the graph is a straight line through the origin. Name a feature of the graph that indicates the presence of a random error. As I mentioned, how you identify or recognize a random error, if the values are spread out, like you have to draw a line of a best fit and the values are spread out, what it does, it means you have a random error. And how you know there's a systematic error? If the graph should be a straight line which is passing through origin, but it has an intercept, it has an x-intercept. So this means there is a systematic error. So random error we identify from distribution of a value around the best fit straight line. And the systematic error we identify that the predicted graph is shifted either all the values towards right or all values towards left. It means there is a systematic error. Because the theory suggests it should be a straight line passing through origin, but it does not have a straight line. So the scattered point shows it's a random error, and the x-intercept shows that there is a systematic error. Question 3, any doubt? Question 3. Question 4, any doubt? Question 4, no doubt? Question 5, 5A. In question 5, part A, question 5A and B, okay. In question 5, an explosion projects a rocket into the not rocket. An explosion projects a rock into the air with a speed of 50 meters per second at an angle of 40 to the horizontal. Show that the rock would reach a maximum height of about 3 seconds after the explosion. So basically what we have to do, we have to just show the time it takes to reach the maximum height. So 50 is a speed, making an angle 40, and this will have the two component. One is a horizontal component, another one will be the vertical component. The horizontal component will be equals to 50 cosine 40, and the vertical component will be 50 sine 40. At the maximum height, the vertical component will be 0, horizontal component will be same if we assume that there is no air opposing the motion. So we can use a formula as we just need the time it takes to, we just have to prove that it takes 3 seconds to reach the maximum height. So we can use a formula that V equals U plus AT. Whenever we use the equations of the motion, we always substitute the vertical component. So what is the vertical component or the final vertical component? It's 0 at the maximum height. The horizontal vertical component is 50 sine 40. So this one is 0. This is equals to 50 sine 40. Acceleration is due to gravity moving against the gravity. So deceleration of 9.8 and t. When we simplify, so 9.8 t is equals to 50 sine 40. If I need the time to reach the maximum height, so it will be 50 sine 40 divided by 9.8. So 50 sine 40 divided by 9.8, that will give us how much time it takes to reach the maximum height, which is 3.27 seconds. So which is about 3 we have to show. Because when the question is about, it's not like you get the same answer. You get the answer which is rounded off to that number. So 3.27, we can say it's about 3. The part B, rock moves in a direction of a hill. The side of the hill is at an angle of 20 to the horizontal, as shown. After a certain distance, the rock lands on the side of the hill. Deduce whether the rock hits the ground before it reaches the maximum possible height. So maybe the rock before, because this is a hillside is there. This is representing the hillside, which is an angle of 20. This angle is 20 degrees. So first, what we have to determine, we have to deduce whether the rock hits the ground before it reaches the maximum possible height. Maybe the rock was going up, like say this was a hill, and the rock was going up and it hits the hill. Instead of reaching the maximum height and then coming down, it might hit before. That we have to deduce. So how to solve this question? So first what we do, we will work out if the rock hits the maximum height, what will be the horizontal distance the rock can travel. So first what we are doing, we are working out the horizontal distance if by assuming that the rock it's a maximum height. So the rock moves the maximum height. So what is the horizontal distance the rock covered? First thing we are finding that part. So how to work out the horizontal distance which the rock covered? We know when it reaches the maximum height, it took 3.27 seconds. That's the time it takes to reach the maximum height. So when the rock is at its maximum height, how much horizontal distance the rock can cover? So what is the horizontal distance the rock can cover? The launching speed, it's the same 50 meters per second. And the angle at which it was launched is 40. So this will have the two component. The horizontal component, which is equals to 50 cosine 40. And the vertical component will also be there. The vertical component will be there, which is 50 sine 40. So the range depends on the horizontal component. So the horizontal range will be the horizontal speed, which is 50 cosine 40 multiplied by time, which is 3.27 seconds. So what is the horizontal distance which this rock will cover if it reaches the maximum height? What is the answer for this? The maximum horizontal distance, like not maximum, it's the horizontal distance which the rock cover when it is at the maximum height. What is this value? 125. So means 125 meters is the distance which this rock will cover. Now, if the rock covered 125 meters horizontally, what will be the vertical distance? Like this is the horizontal distance we worked out. What is the vertical distance or vertical height at which the rock will be present? So how we can work out this vertical height? So the height is equals to, we have to use the equation of the motion by using a formula. S is equals to ut plus half at square. We can use a formula directly as well. We'll get the vertical height same. It won't make difference. You can use the direct formula, like the direct formula for the height, or you can just use the equation of the motion. So if I want to work out the vertical height, so the initial velocity will be 50 sine 40 multiplied by time, which is 3.27 minus 1 by 2. Acceleration is due to gravity 9.8 and the time is 3.27 square. So what is the vertical height this will cover? I will tell a reason why we calculated the range. What will be the vertical height it will cover? So when we simplify this, it will be about 52.6 meters. So means when the rock is at the maximum height, the rock will have a vertical distance of 52.6 and it should have a horizontal distance of 125 meter from the launching position. I took as a negative 9.8. That's why I substitute minus here directly. The gravity I took as negative 9.8 or minus 9.8, and plus minus is minus, so I directly substituted here negative value. So this is a trajectory of the rock. The vertical height, the maximum height is 52.6 and the horizontal height is 125. Now there is a hill which is at an angle of 20. The hill is there at an angle of 20. So what will be the height of the hill? If the length is 125, what will be the height of the hill we are finding? So how we can work out the height of this hill? At an angle of 20 and at a distance of 125. So I will use a tan here. So this is 125 at a distance of 125. What will be the height of the hill? At an angle of 20. So I have the base. I need the perpendicular. So what I can use a trigonometric ratio. I can use a tangent theta, which is perpendicular divided. This h is a perpendicular actually, or the height of the hill, divided by base, which is 125. 125 is divided, other side multiplied. So 10, 20 multiplied by 125. What's the answer? So it will be 45.5 meters. So means the hill is at a height, like the height of this hill at a distance of 125 meter, it is 45.5 meter. And the rock which is released because of the explosion or moved because of the explosion, that rock is at a height of 52.6 meters. So does the rock hit the hillside before it reaches a maximum height? So the answer is no. It does not hit the hillside. Because the height of the hill is only 45.5 meters. If it is 125 meter length, then the height, if at an angle of 20, the height should be 45.5. So what we did, why we work out the range? So we will know the horizontal distance of the rock and we compare the horizontal distance of the hill, and using the horizontal distance, we will find the height of this hill. And comparing the height of the hill with the height of the rock, and if the height of the rock is more than the hill, means it will not hit the ground. Is it clear? Is it clear discussion, or should I repeat? So it means the rock will reach the maximum height and then it will come down. Then it will come down and hit the hill. But at the maximum height, the height of the hill is less than the height at which the rock is present. That's why it won't hit. If you're using the formulas, you give. The formula should also give us the same answer. Maybe the substitution of the value might be different for you. That's why when you're substituting the values, you are getting a different answer. But the formula will give you the same result as is it. Because the formulas are derived from the the equations of the motion. So instead of using the direct formula, I prefer that students should answer according to the equation of the motion. Could you do free body force diagram and expression? The free body force diagram. The free body force diagram for a sledge, as you can see, it is accelerating. So frictionless slope does not have any friction. So the weight will act downward and the R will act perpendicular. But we will not draw the same length for R because the components will be there. The component of the weight will be there. So this is a free body force diagram, weight and the normal contact force. And if you need an acceleration on the inclined surface, which does not have any friction, on inclined surface, the friction is G sine theta. But remember G sine theta for those objects which are having no engine. So A is equals to G sine theta is the acceleration of the object on inclined surface. So if I need an acceleration, it will be 9.8 times sine 6.89. We'll substitute, we'll get the acceleration.